Hi everyone, welcome back to my channel. Today we are going to start with the brand new quiz of Solution Architect Associate exam. So let's get started. So an application that is being installed on an Amazon EC2 instance requires a persistent block storage volume. So we have an application and it is installed an EC2 instance and it requires a persistent block storage. So this seems to be a keyword that we requires a persistent and a block storage volume. The data must be encrypted at a rest and regular volume level backups must be automated. Which solution option should be used? So we also want data to be encrypted at the rest and we want also the backups to be automated. So let's check out our options. First option is use an encrypted Amazon EC2 instance store and copy the data to the another EC2 instance using a cron job and batch script. First of all, Amazon EC2 store is not an persistent storage, so that option is out of store. Let's see the second option. Use an encrypted Amazon EFS file system and use an Amazon CloudWatch event rule to start a backup copy of data using AWS Lambda. So Amazon EFS is a persistent, of course, but we need a block storage, not a file system. So this option also went out. Next is use an encrypted Amazon EBS volume and use data lifecycle manager to automate a snapshot. So yeah, EBS is a block storage as well and it is persistent, and also you can encrypt it and the rest, and you can automate the backups for the EBS by using the data lifecycle manager. So this seems to be a very nice option, but remember, in the AWS exam you don't choose the correct answer, you choose the best answer. So next question might be a more better choice for it. So let's see. That's why I always recommend to check all the 4 options, because sometimes what happens, you see an option or you think this is correct, and later we come to know that there is another better option for it. So next option is use server-side encryption on Amazon S3 bucket and use cross replication to backup on a schedule. So S3 is a object type storage. It is also not an block storage, so it is not our option. So seems like C is the correct option. Let's see. So yeah, C is correct, and you can explore more about it in the short tricks and the concept behind, and where you can see the concept behind each option and why it is false, and which option is correct, why it is true. You can see that, and you can also see there are 2 keywords, block storage, which leave us with the EBS and EC2 install, because Amazon EBS and instance store are the block storage, and the persistence, only EBS is persistent out of EBS and the instance store. So by this way you can directly figure out from the question as well if you want to do it very fast. That's how I figure it out. So let's move to the second question. So you would like to grant additional permissions to an individual ECS application container on an ECS cluster that you have deployed. Okay, so we want to give an additional permission to our application container to only an individual, means there can be multiple containers on the ECS cluster. So ECS is the Elastic Container Service. So you would like to do this without granting additional permission to the other containers that are running on the cluster. Okay, yeah, as we suspected, there are other containers as well on the cluster, but we don't want to give the permission to this, only we want to give an individual container. So how can you achieve it? Okay, mostly the ECS permissions are managed by the task definition and task role. Then let's see our option, what options are available. So first option is use EC2 instance instead, as you can assign different IAM roles on each instance. Yeah, of course we can assign different IAM roles on each instance, but the thing is that we don't want to do that. We want to assign the permission to an individual ECS container. So this is not we want to achieve. So this option is not correct. Create a separate task definition for the application container that uses a different task role. This seems to be corrected because we want to assign it to the individual container. So we created a different task definition, and we also use as a different task role. So task definition is required to run the Docker containers on the ECS. So we have a task definition. So we are creating a different task definition for that particular cluster, and the task definition has attached with a different task role, and that task role contains the permission which we want to give to this individual container. So this seems to be a fairly good solution for our problem. Let's see other option if there are some better options or not. In the same task definition, specify a task role for the application container. Okay, but the thing is that we also don't want to grant additional permission to other containers. So we can't use the same task definition, otherwise we come to allot permission to the other container as well. So this doesn't seem right. You cannot implement granular permission with ECS container. That's not true. You can, as task role is basically an IAM role, and IAM role allows us to implement granular permission. So this option is also not true. So I think B is correct. So let's select B. Yeah, that is correct. Okay. I suggest you never forget to check these concepts and short tricks. It will be very useful for you if you are giving the SAA-C02 exam. It will be very useful for you. Okay, let's move to the next question. A company runs an application on premises that must consume an REST API running on the Amazon API gateway. Okay, so our application is on premises, and that is consuming the API on the Amazon API gateway. The company has an AWS Direct Connect connection to their Amazon VPC. Okay, so if you don't know about this Amazon Direct Connect, it is a service of AWS which allow you to connect your on-premise data centers to the Amazon data centers via a physical cable. So Direct Connect is used to connect your on-premise data centers to the Amazon data centers. And the solution architect wants all API calls to use private addressing only. Okay, so they don't want to use traverse through the internet, I think, and avoid the internet, right? So they want to use the private addressing only, and they don't want to go through the internet. They want to fully make use of this direct connect. So how they can achieve this? So that is our question. So first is use a transit virtual interference and AWS VPN to create a secure tunnel to the API gateway. So transit virtual interference is basically used for the VPC transit gateway, but here in our question it is not that the case. So this is not our solution. We have the API gateway, so we have to make use of that. Second is use a private virtual interference and create a VPC endpoint for Amazon API gateway. So this option seems to be a good option, as we don't want to use the internet and we also want to use the private addressing as well. And we have created a VPC endpoint for the API gateway for our VPC connection. So yeah, we can use this method, and this seems to be a good solution. But we didn't select it right now. We also check the other options if they are better than this or not. Use a public virtual interference and AWS VPN to create a secure tunnel to the Amazon API gateway. So we can't use the public virtual interference, as we want to avoid the internet and we don't want to use the public addressing. We want to use the private addressing. Last option is use a hosted virtual interference and create a VPC endpoint for the API gateway. So hosted virtual interference is basically used to allow another account to use your direct link, but which we don't want in this case. We just want to use the private addressing and you avoid the internet. However, creating a VPC endpoint is our option, which is suitable in the B case also. But we didn't want to allow another account, which is basically when we use the hosted virtual interference, right? So this option is not correct. So B option is correct. Okay, right. This is, so let's move to our next question. A web application is deployed in multiple regions behind an ELB application load balancer. Okay, so in ELB can be deployed in the multiple regions. So by reading the question also you can get many concepts that an ALB is can be deployed in multiple regions or not. So you can see this question also clears our one of the concept. You need deterministic routing to the closest region and automatic failover. So we want to route our request to the closest region, and we want automatic failover also. And traffic should traverse the AWS global network for the consistent performance. And how can this be achieved? So we also want to make use of AWS global network, so we can get getter performance. So it doesn't traverse to the internet, it will make use of AWS global network. We want to use that. So how can we achieve it? So the first option is configure AWS global accelerator and configure ALBS target. So yes, AWS global accelerator definitely uses the global network. So this is a very new service of the AWS, and it is not included in the SSA-C01 exam, the previous version of the exam. But now these new services is included into the new exam. So this is a new question. You should definitely read more about AWS global accelerator. I also have a blog written on it. I will provide the link in the description. You can definitely visit that. So this option seems to be right, as it AWS global accelerator make use of global network, as well as it route our request to the closest region and provides the automatic failover also. Okay. So second option is place an EC2 proxy in front of ALB and configure automatic failover. So EC2 proxy is not using the AWS global network. So this option is not correct. If you want to know more about the EC2 proxy, I have a blog on it. You should definitely check out that. I will provide the link in the description. So create a Route 53 alias record for each ALB and configure a latency based routing policy. So this also seems to be fair, as Route 53 alias record along with the latency based routing policy route our request to the closest region and provide us the automatic failure. But the case is it does not utilizes the AWS global network. So here it fails, and so this can't be our option. Next is use a CloudFront distribution with multiple custom origin in each region and configure for high availability. So yeah, this also route our request to the nearest region, as CloudFront is a CDN service, but it doesn't utilize the AWS global network. Our request will not traverse from the AWS global network. So here it also fails. So our option should be configure AWS global accelerator and configure the ALBS target. So yeah, right. So our last question is, a solution architect just completed the implementation of a two-tier web application for an organization. Okay, the application uses EC2 instance, Amazon ELB, and auto scaling across two subnets. Okay, so application is deployed into the two subnets, and it has the make use of EC2, ELB, and auto scaling. So after deployment, the solution architect noticed that only one subnet has EC2 instance running in it. So we need to find out what could be the possible cause that it is not launched in the two subnets, it is launched in the one subnet. So ELB has nothing relation with the launching of the instance and why it is not running. It just distributed the request to the instances. So auto scaling does have the relationship with the launching instance, as we provide auto scaling configuration, in how many subnets we want to auto scale. So I think a mistake is happening from the auto scaling part. So let's see the options and then we come to the best option available. So cross zone load balancing is not been enabled on the ELB. So this definitely doesn't have anything to do with this situation, as ELB has no relationship with the launching of the EC2 instance. So this option is definitely not correct. The AMI is missing from the ASG launch configuration. So this also not possible. If AMI is missing, then none of the EC2 instance will be running on it, because AMI is responsible, is the base master image on which the EC2 instance ran. Next option is the ELB is configured as an internal only load balancer. As I said previously also, ELB has no relationship with the launching of instance. It just distributed the requests across the instances. That's all. The last is the auto scaling group has not been configured with the multiple subnets. Yeah, that can be a possible cause, because we do specify the subnets in the auto scaling configuration. So yeah, this is the seems to be correct option. Yeah, this is it. I hope you like this quiz and you like this video, and you should like our explanation also. You can go there and read it in very detail. I hope you get the possible information and it helps you to pass the Solution Architect Associate exam. And I also provided in the references the reference link of the official AWS page, so you can explore more. I hope you like this video. Please like this video. It helps me to make more videos like this and push the contents on the website as well. So thank you so much, and don't forget to subscribe the channel.